Hey guys, before we start this unit on limit, I kind of wanted to go over what a limit actually is. So when we talk about limits, we usually use this type of notation right here. And the way you read that is the limit of f of x as x approaches c equals L. Okay, what does that actually mean? What that means is as x is getting closer and closer to some number c, we'll usually tell you what that number is, like it won't be a letter. The y value is getting closer and closer to some number L. Okay, and we have a graph over here to kind of help you visualize that a little bit better. In this picture here, we're doing the limit as x is approaching 2 of f of x, and we're showing that it's going to equal 4 in this picture. And the way we see that, we're showing as when you check to see what the limit is as x is approaching 2, you have to check your one-sided limits first. You have to see what's the limit doing as x is approaching c from the left. And the way we write that is we'll say x is approaching c, and then we'll put a negative on the right-hand side of that number to show that it's going to the left or from the left. And then we're also going to check to see what happens when the limit is approaching c from the right. And the way we'll write that is as x is approaching c with a plus sign on the right-hand side. That's just saying from the right. So in our picture, as our graph, we're looking to see what our graph is doing as you come from the left and from the right. So from the left, we're seeing what the y value is doing, and from the right, we're seeing what the y value is doing. Well, luckily, this one's approaching the same y value. They're approaching 4, and that's why we would say the limit as x is approaching 2 of this function equals 4. All right, so anytime you want to know what the value of a limit is as x is approaching some number, you always check it first from the left, and if it equals some number L, and for some reason I forgot to type this, but you're also going to check it from the right, and if that limit's approaching that same number L, then the limit as x approaches that value c is going to equal L. Just always check it from the left and from the right, and if they're both approaching the same number, then that is your value for the limit. Okay, now we're going to talk about when it doesn't exist. So when a limit doesn't exist, we'll use this notation right here. We'll say DNE, which means does not exist. So an example of pictures where that happens are these three right here. You'll have jump discontinuities. And what happens there is, as you're writing with your pencil, you're writing along, and then all of a sudden you have to jump to go to the next part. That's called a jump discontinuity. So here, if I took the limit as x is approaching 1 of this function f of x, I'm going to get an answer of does not exist. The reason why is because as I come from the left, the y value is approaching this -1 right here. So the limit as x is approaching 1 from the left of f of x, that y value equals -1. But over here, as you're coming from the right, the limit as x approaches 1 from the right of f of x, in this case the y value is 3. Because these are different values, the limit for when x just approaches 1 does not exist. Another time this happens is when you have an asymptote, like we're seeing right here. That's an asymptote. So technically, this limit as of this function f of x as x approaches 3, technically what happens as we come from the left to x equals 3 right here, it's going up to infinity, and as we come from the right, it's going up to infinity. So technically this graph, we could just say it's going to infinity. And that lets the reader know what the graph is doing. As x is approaching 3, the fact that I've said this tells the reader that from the left it's going to infinity and from the right it's going to infinity. Technically, infinity doesn't exist, so we could also say it doesn't exist. All right, and that's called an infinite discontinuity. Anytime you have a vertical asymptote, we have an infinite discontinuity. All right, another example is called infinite oscillation discontinuities. Okay, what happens there? So like if I ask you, what is the limit as x approaches 0 of f of x? Here, again, I would say it does not exist. And the reason why is right here at 0, I don't know what that y value it's approaching. Is it approaching this y value, or is it approaching this y value? It's bouncing up and down, so it's oscillating. So we would say this is another example that does not exist. All right, let's do some actual practice problems.